Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 3.3 variables on both sides. The first two problems are review, so please take a few minutes. Go ahead and try those problems. Pause the video. When you get done, turn it back on. Let's see how you did. Alright, problem number 1. The first step is to combine like terms. Well, I have a 5x here. Do I have another x up there? Yes, I do. It is this positive 3x, so 5x plus 3x would equal 8x. Still be minus 2 is equal to 0. Next step is to get x by itself. The first thing I will move is the operation furthest away from the variable, which is this negative 2, so we'll add 2. 8x is equal to 2. Divide by 8, divide by 8, x would equal 1 over 4. And I did check that earlier. That is correct. Okay. Number 2. You can do one of two things here. I can either divide by 6 to start with, which would leave me with 2x minus 5 is equal to 3. Add the 5. That would get me 2x is equal to 8. Divide by 2, so x would equal 4. And again, I have checked that earlier. That is correct. Or you could have distributed first, which gave me 12x minus 30 is equal to 18. Add the 30. That would give me 12x is equal to 48. Divide by 12, and x is still equal to 4. Either way is perfectly fine. It just depends on which one you're more comfortable with. Okay? If you have to solve an equation with a variable on both sides, there's only one extra step from the two-step equations, and that is making this a multi-step equation. The new step is to move one of the variables by adding or subtracting. I recommend moving the variable with the smallest coefficient, but read and reread the equation first. If you look at number 3 and 4, you will understand why. Just because if you look at number 3 and 4, if I move the smallest coefficient, then you'll have to have some extra steps. We'll see how that works in 1 second. Okay. So if you look at the example that it was just talking about, they subtracted the 8. So 10 minus 8 got me 2y. I kept the negative 19, and then we have a two-step equation. All right. So why don't we go ahead and try these? The first step is to move one of the two variables. What I like to do is try to keep my x positive. So in this case, I'm going to move my negative 5x over to my negative 3x by adding the 5x. That would give me negative 7 is equal to positive 2x minus 17. From here, it's just a two-step equation. I'll have to add the 17. Well, negative 7 plus 17 is 10, which would equal 2x. Divide by 2, x would equal 5. Again, I've checked this earlier, and that is in fact correct. Okay. Problem number 2. Here, this is one time where you want to be careful in which one you move. If I move the 27 over to the 19, then I would have to move the 4 back over to the other side. I really don't want to do that. So what I'm going to do is take the 19x and move it to the 27, which would leave me with 4 is equal to 8x. Need to divide by 8. Divide by 8. 4 over 8 is 1/2, would equal the x. And again, I've checked all these earlier. They are correct. Look at number 3. I could move two things and have my answer already, or I could move the 2w over to the right, and then I would have to divide by a negative. So either way, it's going to be two steps. Personally, what I like to do, again, is I like to keep my variable positive as much as possible. So I'm going to subtract the w over to here. So 16 would be 2w minus w would be positive 1w. Now I'd have to subtract my 16 to get w by itself. So w would equal negative 16. And again, I have checked this earlier. So we're good. Number 4, I can do one step and end this whole problem. How I would do that is just keeping my variable positive. I would subtract the 15x over. That would leave me with negative 3 is equal to x, because 16 minus 15 is 1. And I am done. Again, I've checked that earlier. That's good. Number 5, I want to keep my variables positive, so I'm going to subtract my 2w. That would give me 6 equals 3w. Divide by 3, divide by 3. 2 would equal w. Again, I have checked this earlier, so it is good. Why don't you go ahead and try 6, 7, and 8 on your own. Pause the video. Let's see how you can do. When you get done, turn the video back on, and let's see how you actually did. Number 6, I want to keep my variable positive, so I'm going to subtract the 3x over. That will leave me with x minus 7 equals 0. Only have to do one more step, and x would equal 7. Again, checking that earlier. I know that one is good. Number 7, I want to keep my variable positive, so I need to move the 3x. So I'll go ahead and subtract the 3x. That would leave me with negative 2 is equal to 3x minus 14. Have to add the 14. That would give me 12 is equal to 3x. Divide by 3, divide by 3. 4 would equal x. And again, I have checked it earlier, so that is good. Number 8, I want to make my variable positive, so let's think about which one I need to move over. If I add the 4x to the negative 7x, my variable is going to stay negative. So what I would want to do is add the 7x to my negative 4x. That would leave me with 10 is equal to 3x minus 17. Go ahead and add the 17s. Give me 27 is equal to 3x. Divide by 3, divide by 3. 9 would equal x. I have checked that earlier, and that one is good as well. Now on to the back side. Here it gets a little trickier. Here's 2 special cases. In this situation, it tells us to solve. So let's go ahead and work through number 1 and see what we can do. Well, right now, I know on the left-hand side I can't do anything. On the right-hand side, I can't do anything inside the parentheses, so our first step has always been to distribute the number outside the parenthesis. So leave me with 4 minus 4y. This would be negative 4y plus 4. Okay. Now, I want to try to make my variable positive, but they are both negative 4, so it really doesn't matter which one I move. If I add 4y to both sides, that would give me 4 plus 0y is equal to 4. Now I need to subtract my 4 to try to get the y by itself. Well, 0 times anything is going to get me 0, so that's just going to be 0. 4 minus 4 is also 0. Since that is true, 0 does in fact equal 0. What this means, we call this identity. All it means is an infinite number of solutions. And what that means is it does not matter what I put in for y. I could put 1 million in for y, and it's going to come out 0 equals 0 every single time. Nothing I can put in for y would make that not true. Okay? So let's go ahead and look at number 2. Again, here I have a positive 5n and a positive 5n. So I'm going to go ahead and subtract 5n from both sides. That would leave me 9 plus 0n equals negative 1. To get the n by itself, I'd have to subtract 9. 0 times anything is 0. Negative 1 minus 9 would be negative 10. Does 0 equal negative 10? Well, no, it does not. So what we say here is no solution. There is nothing I can put in place of n to make that equation true. So it would be no solution. Why don't you go ahead and try numbers 3 and 4 on your own. Give it a shot. Pause the video. Come on back when you're done, and let's see how you did. All right, looking at number 3. On the left-hand side, there is nothing I can do, so I'm just going to rewrite the left-hand side. On the right-hand side, though, I can combine like terms. 7x minus 2x would get me 5x plus 5. Here I go ahead and subtract my 5x's. That would give me 7 plus 0x is equal to 5. We know that 0 times anything will get me 0. Go ahead and subtract my 7. 5 minus 7 is negative 2. Does 0 equal negative 2? No, it does not. So our answer is no solution. Okay? Finally, number 4. couple things I could do here. I could divide by 3 to start with, but I'm not going to. I'm going to go ahead and distribute. I'd have 12x plus 3 is equal to 12x plus 3. Well, those are equal to each other, right? Well, that means that I do not have to continue. It's going to be identity or infinite number of solutions. When you have a problem like that, you do not have to write infinite number of solutions. You can write identity or infinite solutions or all real solutions or something along those lines, and they all mean the same thing, okay? So in conclusion, if an equation ends without solving x or solving for x in a true statement like 3x is equal to 3x or 19 is equal to 19 or 0 is equal to 0, then there is or slash r an infinite number of solutions. Okay? If an equation ends without solving for x in a false statement, so like 4 does not, in fact, does not equal 7, right? That does not equal 7. 8 does not equal 0. 3x does not equal 2x. Then there is or are no solutions to that problem. Just means there's nothing I can put in place of x in order to make the equation true, or whatever variable I have at the time. Well, that is the end of the video. Just remember your 2 special cases here. When you solve at the end, if you come up with something like 0 equals 0 or 2 equals 2 or something along those lines, then know that that is identity. That means you can put in any number of solutions that you want, and it will always come out to be true. If you solve your equation and it comes out to something along the lines of 0 is equal to 9, well, we know 0 is not equal to 9, so there can't be any solutions for your variable. It will never make it true. And also remember, when you have variables on both sides of the equation, I always move the one that will keep my variable positive. If that's not possible, I will try to move the one so that my number attached to the variable is as small as possible. And what I mean by that is if I have the opportunity to make it -10 or -5, I'm going to make it -5, not -10. Just will be easier when we divide later. Well, that is the end of the video. Thank you very much for watching, and have a great day.